What if I told you that if ice sank instead of floated, most lakes and rivers on Earth would eventually freeze completely solid, and well, a lot of living things just wouldn't survive? It's one of those questions that sounds so simple until you discover it's actually one of water's weirdest superpowers. So why exactly does ice float on water when most solids actually sink in their own liquids? Welcome to this explainer here on Mastery of English. Today, we're going to find out. I want you to imagine a catastrophic scenario for a second, where this fundamental property of water is just reversed. What if, like almost every other substance on Earth, the solid version of water was actually heavier than its liquid form?
Well, it would trigger a relentless, deadly chain reaction. Picture this. During the winter, the surface of a lake freezes. If that ice was heavier, it would sink straight to the bottom, right? Then the newly exposed water on top would freeze, and guess what? That new ice would sink too. Eventually, entire lakes and rivers would freeze completely solid, literally from top to bottom. The result? Absolute ecosystem collapse. Fish, plants, frogs, they'd have absolutely nowhere to survive. Entire food chains would just disappear.
So to understand how nature avoids this icy apocalypse, we need to look at a crucial science word today: density. Put simply, density is just the amount of matter, or mass, packed into a specific space. For example, iron has a much higher density than water. Density is going to be the absolute core metric of our investigation today into why water behaves so strangely.
Let's ground ourselves in normal physics for a second to really appreciate this. See, most materials in nature become smaller and significantly denser when they freeze. Think about things like melted candle wax or molten metal. As they cool down, their particles move closer together, they contract. But water completely defies these expectations. It is a bizarre exception. Our job now is to figure out exactly how water breaks these normal rules of physics.
To find our culprit, we've got to zoom way down to the microscopic level and look at another key word: the molecule. A molecule is simply the smallest group of atoms that forms a substance. If we want to understand why ice floats, we have to look really closely at the exact shape and behavior of water molecules.
And here's the fun visual for you. A single water molecule actually looks a whole lot like Mickey Mouse's head. You've got one larger central oxygen atom acting as the face, bonded to two smaller hydrogen atoms positioned at angles up top, acting like the ears. When water is in its liquid state, these tiny molecular Mickey Mouse heads move around freely. They stay close together, but they're constantly moving and changing their positions.
But right here is where we hit a massive pivot point in our mystery. Look at this exact temperature: 4 degrees Celsius. As liquid water cools down to exactly 4 degrees, it actually follows the rules. It behaves like a normal substance and gets progressively denser. But the very moment the temperature continues dropping below 4 degrees, boom, everything changes.
Enter the magical force that takes over the whole operation, the hydrogen bond. This is a weak but super important force that attracts water molecules to each other. When that temperature drops below 4 degrees Celsius, these hydrogen bonds start exerting some serious power over those Mickey Mouse-shaped molecules.
Now, remember, in normal freezing, substances squeeze tightly together to pack as much matter into a space as possible. But look at water. Instead of compressing, those hydrogen bonds systematically arrange the water molecules into a highly organized, spacious crystal structure. The molecules literally push each other away to form this open pattern. It's wild. Okay, to translate all this abstract physics into something instantly understandable, let's use a super simple, everyday analogy. I want you to imagine two identical backpacks sitting right in front of you. Both contain exactly 10 books. So the mass, the total amount of stuff in those backpacks, is completely identical. But notice how they are packed. Backpack A has those 10 books compressed and squeezed really tightly together. But Backpack B has the exact same 10 books spread much farther apart, maybe with rigid dividers holding them in an open pattern. Even though they have the exact same mass, Backpack B takes up way more physical space. And that is exactly what happens when water turns into ice. It essentially turns into Backpack B.
Which brings us to the fundamental conclusion of our mystery today. When those hydrogen bonds force the water molecules to spread out and expand, that exact same amount of water now occupies more space. And more space with the exact same mass means lower density. Because ice is less dense than liquid water, it floats.
Let's zoom back out to the big picture to see why this matters so much. This bizarre molecular quirk basically acts as a protective biological blanket for the Earth. Because ice floats, it stays right on the surface of lakes and rivers. This surface layer acts like an insulator. It drastically slows down any further freezing and preserves the liquid water underneath. This means fish, frogs, and plants can actually survive the freezing winter. One unusual property of water literally supports ecosystems all around the world.
When you step back and look at the facts, it's pretty staggering. First, ice is about 9% larger in volume than the liquid water it came from. Just think about that. A mere 9% volume increase protects entire planetary ecosystems. Second, water actually reaches its highest density at about 4 degrees Celsius, not at its freezing point. And finally, most solids sink in their own liquids, making water an incredibly unusual yet absolutely essential exception to the rule. As we wrap up this explainer, I want to leave you with a question. What other familiar things conceal the biggest scientific surprises? Water seems so totally ordinary to us, yet its ability to expand when freezing gives it extraordinary properties that allow life on Earth to even exist. Sometimes, the most everyday things hide the most incredible scientific miracles. Thanks for joining me on Mastery of English today, and keep wondering about the world around you.